want to take you through the assessment, and here is part 1. I'm just going to do trial 1, and the first thing I notice is the puck, which is stated up above, travels at constant velocity, states there's minimal or negligible friction. What I'm going to go ahead and do is open up a horizontal ruler, and I want to get it just right when the puck leaves the finger, and I'm going to go ahead and set 0 at the back of the puck. I'll get my stopwatch and reset the time. I'll find out the change in position and the change in time. And I'll go ahead and graph that on a position clock reading graph. So as I advance this frame, I notice that it is moving forward or to the left, and I'm just going to go for 10 centimeters. I notice that the puck has changed its position by 10 centimeters in 0.0542 seconds. Some of you like to just start with a data table, so I'm going to go ahead and just call it started at 0 clock reading and 0 position. The clock reading was 0.0542 seconds, and the position was 10 centimeters. But in this case, I'm going to call it 0.1 meter. Some of you know how to do this. Y equals mx plus b. I know b is going to be 0, and I'll go ahead and set my slider. And that looks appropriate. Maybe I'll slide in a little bit more, and I can get pretty accurate. I might even, I know it's about 1.8, so maybe I'll go from 1 to 2 and change my step and get it real tight in there. So it looks like my velocity might be 1.85 meters per second. Okay, I know in snapshot 1 that the velocity is 1.85 meters per second, and that is from Desmos. The mass I'm still not quite sure of, so I'm going to go ahead and just put a question mark there for now. But I do know that the height is also 0, or I'm just going to let that be my reference of 0. So snapshot 2 is going to be some height, because that's the question, is how high does it go? But I do know that at its peak, or at its highest point, that it is traveling at 0 meters per second. So snapshot 1 is going to be all EK. Snapshot 2 is going to be all EG. So if I were going to draw a little diagram, it might look like this, where I have all EK and all EG. So my qualitative conservation is EK equals EG. So I might look at this and say, well, 1/2 mv squared equals mgh, and that h is what we're looking for. Well, some of you algebraically can quickly see this, that the m's divide out. This transfer of energy is independent of the mass. So no matter what mass that puck is, it'll go to the same height. So let's go ahead and put some numbers in this. I'll go ahead and ignore the mass because it divides out. So 1/2, 1.85 squared equals 10. H. My gravitational interaction, or my gravitational field strength, is 10. So I end up with an answer of H. H equals 0.17 meters, or 17 centimeters. For now, just so you can see, I can write 18 centimeters. I'll go ahead and lock that answer in, and then I'll go to my prediction. Still in trial 1. I'll go ahead and watch this again, and now it goes up. It goes to that height. So let me come back a little bit here. Open up some tools. I'm going to go ahead and open up this line here, and I'm going to go ahead and put it right here so I can hopefully recognize that that is right on the center of that, which is fine. You could put it anywhere you really want, but I'm going to go ahead and put it on the center, and I'll go ahead and back this up, advance that just to where it stops. That looks about right there. I'll go ahead and put a dot there, right on the center again. And then I'll go ahead and get my horizontal stick, go ahead and put that at 0. It looks like I get, well, let's see, that's 15, 16, 17.5. So it looks like I get to about 17.5 centimeters.